It is correct. So now let's try. Probability that a random sample of 17 has a mean between these two. All right. 17. So instead of a sample size of 5, we now have a sample size of 17. So let me copy and paste most of this work. Okay, so let's see what I get. Okay, so this is B part. Now n is 17. Mu is the same, but standard deviation of x bar is sigma over square root n. So now that is a 17. 52 over square root 17. Okay, they are telling us 17. So I need to calculate that. 52 over square root 17. That gets me standard deviation of so much, right? 12 points. So previously I had 23. Now I have even smaller standard deviation. Of course it makes sense because the denominator has become bigger. So the fraction value has become smaller. So now what are the limits for x bar? Same, 595 to 601. 595 to 601. So this will change. Okay. All right. Now z is x bar minus its mu over the new standard deviation. So when n changes, standard deviation changes. Okay. And that is because standard deviation of x bar is, let me write down the formula, sigma over square root n. Okay, so as n changes, my standard deviation of x bar changes. All right, that's the only change. Method, everything else is the same. So instead of 23, now I have 12 in the denominator. Instead of 23 some odd, I have 12 some odd in the denominator. Everything else is the same. So that will change. So will this. Okay. So these numbers will change out here. Okay. So let's figure out this number. Correct? So first one is 595 minus 585 over 12.6118525. Okay, so that's the left hand number. And for the right hand, I need 601 here. That's all the difference. Okay, so I try to avoid approximating until this point. Now I can approximate. 7, 9, the following number is 2. So 0.79 is fine. 2, 6, the following number is 8. So I will say 1.27. Okay, so we need areas between these two numbers. So 0.79 is the smaller number. 1.27 is the bigger number. So we need to find the areas for these two numbers. So the bigger number is 1.27. 1.27. So 1.27. That's the number. 0.8980. 0.8980 minus smaller number is 0.79. 0.79. Okay, so 0.79. 7852. 7852. Okay, so these are the two numbers. their difference we need. All right. 0.8980 minus 0.7852. Let's submit and check. It works. Good. The third one. Random sample of 23 has mean between the two things. So the problem C is exactly the same, but now my sample size is 23. So let me copy and paste this argument. I get a 23 here. So mean is the same. Standard deviation is the only one that has n in its formula. So that will change. Okay. So instead of 17, now I have 23. So 52 over square root 23. So we need the calculator. 52 over square root 23. That's 10 point some odd. Okay, so that's 10 point some odd. And this will change because standard deviation has changed. These numbers will change because standard deviation has changed. So notice x bar minus mu of x bar and standard deviation of x bar, which has changed. So this is going to change. So it's only the standard deviation which changes when n changes. Okay, so that will mean these numbers will change and these numbers will change. Okay, so let's figure out what these numbers are. That's here. So something divided by, let's go read this off, 10.84274953. All right, what goes inside is 595 minus 585. So I get that as my first number, and with 601 here, that as my second number. Okay, now at this point I can approximate. That's a 2.92, following is 2, so no change, 0.92. Here 475, so I'll make it 48, so 1.48. So here is 0.92, whereas here is 1.48. How do we find area between two numbers? Find the area for the bigger one first, 1.48. So 1.4 is here, 8 is over here. So coming down, 9306, 0.9306, that's the area for the bigger number. Now let's go look area for the smaller number 0.92, 8212, 0.8212. So that's my final answer here. 0.9306 minus 0.8212. Okay, something went 8212, not 83. All right. Okay, so that completes this entire set because there was only one problem here. Okay, so next video will cover questions from section 7.6. Until then, bye.